Okay, let's make the substitution. And one thing I like about definite integrals, it's easy to make the substitution now because I just go from the land of x to the land of theta. So let's do the limits first. So if x is 0, I'd have, let's see, 3 sine theta. And the only way for that to occur on the invertible region, and again, the invertible region for this is between minus pi over 2 and pi over 2. The only way that occurs if I get theta to be 0. All right? Now let's do the other one, 3 over 2. And that's 3 sine theta. And that's going to be, let's see, 1/2 equals sine of theta. And that's not too bad either. I'll draw a little triangle down here for you. 1, this is going to be 2, and this will be root 3. And that means this is 30 degrees. Well, 30 degrees is going to be pi over 6. Okay, I got that. Now I got to pop everything in now. What's x squared? It's 9 sine squared theta. What's dx? It's 3 cosine theta d theta. All right? Then what do you get in the bottom? You get 9 minus, x squared would be 9 sine squared theta. All right? Let me keep going. And what do I see? I see 9 times 3, which is 27. And then you get sine squared times cosine theta d theta. All right, what do you get in bottom? And this is going to be, you factor the 9 out. I put what I mean by that, 9. I'd get 1 minus sine squared. And that's going to be 9 cosine squared theta. And the interesting thing about this, if you're in that invertible region, the cosine is going to be non-negative. So I could take the square root of that. So you'd get a 3. The square root of 9 is 3. And in that region, the square root of cosine theta is cosine squared, just cosine theta. Now, granted, there is an issue maybe somewhere, but I'm going to say conditionally, these things will cancel off. They're not, they're non-zero, all right? So what do I left off? I'm left off with 9, 0, pi over 6, and then I get sine squared d theta. Remember, we have identities that we deal with. They're double angle identities. You should know them from pre-calculus. 1 minus 2 sine squared theta. So, I could say sine squared theta is 1 minus cosine 2 theta over 2. Okay, let me put that down. I'm going to factor the 2 out, so it's 9/2, 0, pi over 6, and that's going to be 1 minus cosine 2 theta d theta. I can integrate now, 9/2. The antiderivative of 1 is theta. The antiderivative of cosine is going to be sine 2 theta over 2, and that limits of integration go from 0 pi over 6. All right, I'm going to erase here. I get some extraneous stuff over here I don't need anymore. Okay, let me see if I can do it. So what do you get? Equals 9/2 pi over 6 minus sine. Well, 2 times pi over 6 is pi over 3. We'll do that in a moment. Over 2. Let me do the lower limit, 9/2, 0. And 2 times 0 is 0, and the sine of 0 is 0. So I got only one computation to do now, which is pi over 3. Pi over 3 is 60 degrees, so the triangle looks like this over here. And that's going to be root 3, 2, and that'll be a 1. So let's write this down, 9/2 pi over 6 minus, you get a 2 there, and the sine of pi over 3 is root 3 over 2. Now, granted, I need to clean that up, so 9/2. This is going to be pi over 6, and this will be root 3 over 4. I'm going to keep simplifying it. I want to get it nice and neat. 9 over 2. I'm going to say a 12 there. 2 pi, and this would be what? 3 root 3. All right, let's see what we got there. Let's see if we can simplify it. I'm going to divide by 3. This becomes 3. This becomes 4. And you get 8 now, because 2 times 4 is 8. And then you get 2 pi minus 3 root 3. Let me say I said that right. Yeah, times 3. Get my eraser up, make it nice and neat. Look at the key. Did you get that answer? 3/8. I did it again. 3/8. I see that. 2 pi minus 3 root 3s. We're doing fine. Thank you.